In this video, we're taking a detailed view on the microtubule remodeling process. Let's take a look at the microtubule dimers. As we already know, the dimers are made up of alpha tubulin and beta tubulin. These tubulin binds GTP, and up top we see the beta tubulin, where the GTP can be converted to GDP. And the effect that this has is that dimers with GDP bound to them have the ability to bend more compared to GTP bound dimers. And so at the end of a microtubule filament, there's a GTP cap that gives the filament structural integrity by preventing it from bending too much. But if we lose this, the tubulins won't be kept together thanks to this loss of structure much, and it will become unstable. And as a result, it will depolarize rapidly. And this is called that catastrophe is taking place. And it will continue until a GTP cap is formed again. And this is known as a rescue phase. Now we're going to take a look at how treadmilling looks like for the microtubule filament. Normally, microtubules polymerize, and in this case, it's at a protein site at the centrosomes. And we see that GTP dimers are first bound to the microtubule and are then hydrolyzed into GDP dimers. And so again we see this GTP cap at the end. But there are cases where the microtubule nucleate at the centrosome site and then detach from the centrosome, and it's this detached form of the microtubule that can undergo treadmilling. First we're going to look at a Wegener model, which is basically the same as the treadmilling process of actin filaments, where tubulin from the negative end will depolymerize at the same time as there's a polymerizing process at the positive end. And as we know from the actin filament video, this is a result of the difference in affinity for tubulins at the negative end and the positive end, where the concentration for polymerization is lower at the positive end. Then there's another model that takes into account the catastrophe phase and the rescue phase into account, where we can have a rapid depolymerization at one end while we have a polymerization at the other end. Lastly, let's take a look at a few remodeling proteins. Microtubules have these plus tips proteins that recognizes the positive end of the microtubule and binds to it. And to this plus tip protein, other proteins can bind. For example, this XMAP215 protein, which is one of many proteins that help with polymerization. But there's also many proteins that help with depolymerization. And in this video, we're taking a look at the MCAK protein. It also binds to the plus tip protein and causes depolymerization at the positive end of the microtubule. And that covers everything for this video. I hope you learned something. Thank you.